Hi, so we will be learning about the t-distribution today, and the t-distribution is used in so we will be learning about the t-test today. This is used in class 12 applied mathematics and also in statistics courses. We learn what is a t-test, what is a one sample, two sample, a paired t-test. We'll also learn about the t-distribution table and how to calculate the test statistics, degrees of freedom, and the rejection rule using p-value and critical value. We will also be introduced to the tabular form of the t-distribution table. Two problems are discussed here, one with the upper tail test and the other with the two-sample test. So let's tune in. So what is a t-test? A t-test is a statistical test used to compare the means of two groups. If one group is being compared against a standard value, we use a one-sample t-test. And for a two-sample t-test, if the groups come from two different populations, then we use that. If the two groups come from the single population, one population, we form a paired t-test. So we have a one-sample t-test, a two-sample t-test, and a paired t-test where the two groups come from the same population. Now, t-distribution is a continuous probability distribution. It is used to estimate the mean of a normally distributed population when the sample size is small and the standard deviation is unknown. So basically it is used to estimate the mean of a normally distributed population. The t-distribution depends on a parameter called degrees of freedom, and the degrees of freedom depends on the number of values that are free to vary. So there is a formula to calculate the degrees of freedom for the t-distribution. It's a very simple formula. The t-distribution with more degrees of freedom closely resembles the normal distribution, and the mean of the t-distribution is 0. So for a normal distribution, we have it here, and this is the t-distribution. So you can see how close they are. Now we have the lower tail, upper tail, and the two-sided test, and there are some formulas which will help you to determine the values. So we have the null hypothesis, which is H0. For a lower tail test, mu is greater than or equal to mu naught. HA is mu is less than mu naught. For an upper tail test, the hypothesis will be mu less than or equal to mu naught, and HA will be mu greater than mu naught. For a two-sided test, the null hypothesis is mu equal to mu naught, and the alternate hypothesis is mu not equal to mu naught. Again, you have the test statistics where it is given by the same formula t equal to x bar minus mu naught s by root n, where s is the standard deviation. And the degrees of freedom is the very simple formula for all three. It is n minus 1, where what is n? N is the sample size. Again, you have the rejection rule using the p-value. We reject H0 if the p-value is less than or equal to alpha for all, one sample, two sample. Then you have one lower tail, upper tail, and two-sided test. And critical value approach, for a lower tail test, you reject the null hypothesis if t less than or equal to minus t alpha. For an upper tail test, we reject H0 if t greater than or equal to t alpha. And for a two-tail test, we reject H0 if t less than or equal to minus t alpha by 2 or t greater than or equal to t alpha by 2. So we have seen the values for a lower tail test, upper tail test, and a two-sided test. Now points to note for a one-tail test, that is the upper tail test, if t equal to 1.75 and the degree of freedom is 50. And I have actually given the one strip of the t-distribution table. Now t is 1.75, and you can see that 1.75 lies between here 1.676 and 2.009. So we go in the reverse order. The p-value will lie between 0.025 and 0.05. For a lower tail test, if t is minus 1.75 and degree of freedom is 50, since the area under the curve to the left of t is same as the area under the curve to the right of t, because the curve is symmetric, again the p-value will lie between 0.025 and 0.05. So we basically look at the same value, whether it is lower tail or upper tail. For a two-tail test, double the area. For example, if t is 1.27 and the degree of freedom is 25, I have again given you a strip of the t distribution table. So 1.27 lies between these two values. So p value will lie between 2 into 0.10 and 2 into 0.20. So we are multiplying it by 2 for a two-tailed test. That is between 0.20 and 0.40. So now coming to problem solving, consider the following hypothesis test. The null hypothesis is mu less than or equal to 12. Alternate hypothesis is mu greater than 12. A sample of 25 provided a sample mean x bar is 14 and a sample standard deviation s equal to 4.32. Compute the value of the test statistics. Now this is an upper tail test. So we just put down the parameters. What are the values given? N is 25, x bar is 14, sigma or s is 4.32 and the null hypothesis mu naught is 12. So the value of the test statistics remains the same, that is x bar minus mu naught by s by root n, and substituting these values of x bar, mu naught, s and root n, we get t as 2.31, and degree of freedom, there's a simple formula n minus 1 which is 24. Now use the t distribution to compute a range for the p value. So we are looking at 24 degree of freedom and t is 2.31. So I'm just going to scroll up to the t distribution here. So we have t, look at the degree of freedom is 24 and 2.31. So 2.31 will lie between 2.64. I'm just going to expand it a little. It lies between 2.31 lies between 2.064 and 2.492. So the p value will lie between 0.01 and 0.25. So we have the p value will lie between 0.01 and 0.025. And this is what is rejection rule using the critical value at alpha is 0.05. So using the critical value, we reject H0 if t greater than or equal to t alpha. Now what is t 0.05? Again, if you look at the table here, you have 0.05 degree of freedom 24. T 0.05 is 1.711. You can see 0.05 here. So we can say that the t 0.05 is 1.711 and your value of the test statistic is 2.31. It's what you calculated in the first part. So 2.31 is greater than 1.711, so we reject H0. What is your conclusion using the p-value approach? Using the p-value approach, we reject H0 if p-value less than or equal to alpha. Your p-value you just calculated is less than 0.025, which is less than 0.005. So alpha is 0.05, sorry, it is less than 0.05. So we reject H0. I'm just going to write it as 0.05. So we reject H0. Now coming to the next question, consider the following hypothesis test. Mu is 18 and alternate hypothesis mu is not equal to 18. So the null hypothesis is mu equal to 18. So what sort of a test is this? This is a two-tailed test. The sample size is 48, sample mean x bar is 17, sample standard deviation s is 4.5. So these are the parameters given to you. You have to calculate the value of the test statistics. So that is given by t equal to x bar minus mu naught s by root n. So x bar is 17, mu naught is 18, s is 4.5, n is 48, so root 48. So you get minus 1.54. And the degree of freedom, what is the formula? N minus 1. So 48 minus 1 is 47. Now use t distribution table to compute a range for the p-value. So again we are looking at 47 and minus 1.54. So going to the t distribution table here, we have 47 is here and 1.54 will lie between 1.300 and 1.678, that is between 0.05 and 0.10. So we can say that the value will lie between 0.10 and 0.20. 0.05 and 0.10, and because it's a two-tailed test, p-value will lie between 0.10 and 0.20. So once more, 1.54 lies between 1.3 and 1.68, so the area lies between 0.10 and 0.05 and 0.10, and we multiply by 2 because it's a two-tailed test, so it will lie between 0.10 and 0.20. And if alpha equal to 0.05, what is the rejection value using the p-value method? The p-value is greater than 0.10, which is greater than 0.05, so we do not reject H0. We reject H0 if the p-value is less than or equal to 0.05. What is the rejection rule using the critical value approach? Now, using the critical value approach, we reject H0 if t less than or equal to minus t alpha by 2 or t greater than or equal to t alpha by 2. Now, t alpha by 2 is t 0.0025. So again you look at the table with the degree of freedom as 47 and 0.025. So I'm going to scroll up. You have degree of freedom is 47 and 0.025. So 47 with 0.025 will give you 2.012. So when you go to that, coming back to the question, you will get it is 2.012 and t is minus 1.54. That's what you got by your calculation in the first part. You can see here it's minus 1.54, which is greater than minus t alpha by 2, that is minus 2.012. So we do not reject H0 because your t has to be less than or equal to minus t alpha by 2. It is not less than or equal to minus t alpha by 2. It is greater than minus 1.4 is greater than minus 2.012. So we do not reject H0. So points to remember, this can come as objective questions or multiple choice questions. For a t distribution, the sample sizes are drawn from a normally distributed population. If we reject the null hypothesis, we make a type 1 error, and greater the degree of freedom, the more the t distribution resembles the standard normal distribution. So we have learned to use a t-test, what is a one sample, two sample, and a paired t-test. We have learned about how to read the t-distribution table, how to calculate the test statistic, degrees of freedom, rejection rule using p-values and critical values. And we have also learned how to do problem solving, one with the upper tail test and one with the two-tail test. So thank you, and do like and share my class. Thank you.